Alright students, here is a solution for question 2 from Classwork 1. So let's see what we got going on here. We got a table with years and meters. So they say that the height of the tree at time t is given by a twice differentiable function h, where h of t is meters in meters, is measured in meters, and t is measured in years. Selected values of h of t are given in the table above. Use the data in the table to estimate h prime of 6. Using correct units, interpret the meaning of h prime of 6 in the context provided. Alright, and then question B, explain why there must be at least one time t for 2 is less than t is less than 10, such that h prime of t equals 2. Part C, use a trapezoidal sum with the 4 subintervals indicated by the data in the table to approximate the average height of the tree over the time 2 is less than or equal to t is less than or equal to 10. Part D, the height of the tree in meters can also be modified by the function d, modeled by the function g, given by g of x equals 100x over 100 plus x, where x is the diameter of the base of the tree in meters. When the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.03 meters per year. According to the model, what is the rate of change of height of the tree with respect to time, in meters per year, at the time when the tree is 50 meters tall? Alright, we got a lot going on here. We're going to take it one question at a time. So question A, use the data in the table to estimate h prime of 6. Using correct units, interpret the meaning of h prime of 6 in the context of the problem. So because we're not given the value for 6, we're going to have to do an estimate. We're going to use one value below, that'll give me using the 5, and one value above, that will be using the 7. So h prime of 6 will be the h of 7 minus h of 5 over 7 minus 5. We know that h of 7 is 11, h of 5 is 6, and 7 minus 2 is 2. 7 minus 5 is 2. So that's going to be 5 halves. They ask me to interpret this, so that's 5 halves. My units would be meters per year. So that would mean the tree grows at a rate, now this next word is important, approximately of 5 halves meters per year. Now it's important that we write the word approximately because we don't have a guaranteed answer, and that's something they're going to be looking for in the AP exam. Alright, let's take a look at question B. So question B, explain why there must be at least one time t for 2 is less than 10 2 is less than t is less than 10, such that h prime of t equals 2. So for question B, there's a couple ways you could do it, but I'm going to do the fast kind of cheater method. I can see that from 3 to 5, that's a 2-year jump, and then 2 to 6, that's a 4-meter jump. So I can see that h prime of 5 minus h prime of 3 over 5 minus 3 equals 4 over 2 equals 2. Because that means from somewhere on my graph I have a slope of 2. We can say that by the mean value theorem, there must be some point, we'll say C, that's between 3 and 5, where h prime of C equals 2. Now this is the shortcut, fast way if you know what you're looking for. But if you don't know what you're looking for, there's a few other methods you could use. If you have a different method and you want me to check it, send me a message and I can check it through WebEx. Okay? This is the method that I'll post here. So let's check question C. So question C, use a trapezoidal sum with 4 subintervals indicated by the data in the table to approximate the average height of the tree over the time interval 2 is less than or equal to t is less than or equal to 10. Alright, so we're going to be doing a trapezoidal sum. So I'm going to try to give myself some space here because they take up some space. There we go. And again, these answers are already in the paper that I have on Teams, so you can check your answer there. So I'm using a trapezoidal sum. You could, if you remembered the formula, that's great. I don't like remembering formulas. I think it's easier if I just remember processes. So we can see we go from 2, 3, 5, 7, 10. So 2, 3, 5, 7, 10. And then 1.5. Now let's label 2, 3, 5, 7, 10. 1.5, 2, 6, 11, 15. So we're going to go bam, bam, thank you, man. And these are going to be my trapezoids. Alright, so we got area 1, area 2, area 3, and area 4. And those are the 4 subintervals they'd mentioned in the problem. So if you remember the formula for a trapezoid, the area of a trapezoid, it's base 1 plus base 2 over 2 times height. So area 1 is going to be 1.5 plus 2 over 2 times 1, which will get you what? What is that? 3.5 divided by 2. So what's that? 1.75. Yep. Area 2 is just going to be 2 plus 6 over 2 times 2. Well, this 2 is a difference from 3 to 5. That's going to give you 8. Area 3 will be 6 plus 11 divided by 2. Difference between 5 to 7 is 2. So that's 17. And area 4 will be 11 plus 15 divided by 2 times 3. So that would be 11 plus 15 is 26. 13 divided by 3 is 39. Now here's an important thing you have to realize what they're asking you. They're asking for the average height. So that means we're going to add them all up. 1.75 plus 8 plus 17 plus 39. Because they're asking for the average, we're going to use this entire span. So 10 minus 2. Or as you can see, it's 8. When you put this into a calculator, give me a second here. You'll get 65.75 divided by 8, which as a decimal is 8.22. And the units, it's the average height, so just meters. In fact, that should be part of my answer. And that is question C. Now part D is probably the trickiest question because they throw you a curveball in there, and I don't know if you caught it when I was reading it. So let's read part D again and see if you can hear the tricky part. So D, the height of the tree in meters can also be modeled by the function g given by g of x equals 100x over 1 plus x, where x is the diameter of the tree, where x is the diameter of the base of the tree, that's important, in meters. When the tree is 50 meters tall, the diameter of the base of tree is increasing at a rate of 0.03 meters per year. According to this model, what is the rate of change of the height of tree with respect to time in meters per year? at the time where the tree is 50 meters tall. So here is the problem. They're asking me with respect to time, but g of x is not given with respect to time. So what we have to do is this x is actually a function of time. So we can't just make x be that. It's equal to some type of, something's going on with t in there. We're not sure what it is. You'll see how that shows up later. So they want the rate of the change of height. So that means they're asking me for g prime of x. They tell me that g of x is equal to 100x over 1 plus x. We can see that we're going to have to use the quotient rule here, which, if you don't remember, the quotient rule states that the derivative of u over v is u prime v minus uv prime over v squared. I'll rewrite that again. So let's pick a u. U will equal 100x, and my v then will equal 1 plus x. So the du, or the u prime, now this is where I mentioned the x is a function of something. What we're going to have to do is we can't just let x be dx. The derivative of x is going to have to actually be dx dt. Normally we would have written this, 100 dx. But because we know that x isn't just a value, it's actually a function of time, we're going to have to say dx dt. And the same thing over here, v prime. The derivative of 1 still just goes away, but my derivative of x has to become dx dt. And that's because x is not measured in time, and they ask me with respect to time. So then that means that g of x, once we apply the quotient rule, we're going to have my u prime v minus u v prime all over v squared. So they're asking for the rate of change of height in meters per year. So that means my answer is going to be a number, which means we're going to have to plug in for things. So we're going to have to plug in. I'm going to need to find my dx dt. And I'm also going to have to find something to plug in for x. So let's reread the question. Is there any data we haven't used yet? The height of the tree in meters can also be modeled by the function g, given by g of x equals 100x over 1 plus x, where x is the diameter of the base of the tree. When the tree is 50 meters tall, all right, there's a number we haven't used. The diameter of the base of the tree increases at a rate of 0.3 meters per year. Okay, so here's my rate. So that's going to be 0.03. And now my 50 is the height, which we said was g of x. So then that means that g of x, that should be g prime, equals 50. So we want this x here. So we're going to plug this in for 50. So that means we're going to do 50 equals 100x over 1 plus x. Bring over the 1 plus x. You'll get 50 plus 50x equals 100x. That gives you 50 equals 50x. So x will equal 1. So now I'm ready to plug in. So that means the width of the tree, what we're going to plug into our g of x, is 1, and our derivative is 0.03. So plugging in to g prime of x, again, that was our big function here. That'll give you 100. We said our dx dt is 0.03 times 1 plus x, which was 1, minus 100 dx dt, 0.03, sorry, 100x, x was 1, dx dt, all over 1 plus x, which was 1, squared. Since this is to the 100th times 100, that's just going to be 3. 1 plus 1 is 2, minus, again, 100 times 0.03, so 3. 1 plus 1 is 2, squared is 4. 3 times 2 is 6, minus 3 is 3 over 4. And again, what are the units they asked for me before here? It's going to be in meters per year. That's a little bit of a tricky question. If you want me to go over it some more, talk to me in the live chat or schedule an appointment. That has been Classwork 1, question number